All right, so one of the things that we have not gone over together yet that will absolutely be in your coursework next semester, you just put those on the floor or something if you want, are exponentials and logs, okay? 100% review. I chose not to start with the lesson that's actually before this is where we graph exponentials. Just because we'll talk about the transformations and stuff, but I don't feel like we need to actually get on graph paper and graph them. So I'll just remind you of a couple of things. If I have an equation like y equals 2 to the x power, that is an exponential function because the variable is in the exponent. That would represent exponential growth, which would look something like this, something that grows very, very quickly, okay? Exponential graphs have asymptotes because I have a, oh, well, it's trying to change colors. I have a horizontal asymptote right there at y equals 0 because there is not a number I could substitute in for x that would give me an output of 0 or a negative number. Like it can be a really small number, but it's not going to change the sign on the answer there. If I have y equals 1/2 to the x, that would be exponential decay because that b value is between 0 and 1. Okay, so I just want to make sure we understand what exponentials look like. Got exponential growth, decay. I know you've done lots of application problems of those throughout time. Okay, today we're just going to look at solving a couple of different kinds of equations. There's different ways to solve them. Today we're just going to look at common bases, and we're not going to do all of them. All right, so let's look at number 1. I have 2 to the x plus 1 equals 2 to the 9th. If you have a single exponential on either side of the equation, on either side of the equal sign, then you can drop the bases, which is 2, and set the exponents equal to each other. So x plus 1 equals 9. So x equals 8. And if we substituted 8 back in, that'd give me 2 to the 9th equals 2 to the 9th, and hopefully that makes sense. That's why you get to just drop the bases. There's a one-to-one property that allows you to do that. You can prove it using logs and stuff. You can just take my word for it right now. So when I look at number 2, I've got, again, a single exponential on either side with a base of 5. The bases match. So I can drop my bases and just get 4n plus 5 equals n minus 7. And then it's just a simple 2-step problem.
Thank you.
And this is going to give me 3n equals a negative 12. So n equals negative 4. All right. Everybody good so far? So looking at number 3, do you think it would be legal for me just to drop my 3's right now? Do I have a single exponential on either side of the equal sign? I do not. I've got a single one over here, but I've got 2 being multiplied over here. And if you're going to multiply 2 terms with the same base, what is the rule for the exponents? What do you do with them? Add them. If you multiply 2, so because if I had, let's do this up here. If I had x squared times x to the 3rd, that gives me x to the 5th, right? We know that, and that's because we added the exponents. So here, this would give me 3 to the k plus 3k plus 2 equals 3 to the 5k minus 1. So now I have a single exponential on either side of the equal sign. I can drop my 3's. I'm going to combine this and get 4k plus 2 equals 5k. What did I do wrong? That's a very, very good question where I got the 3k from. I don't know where I got the 3k from because that makes absolutely no sense. Sorry about that. Thank you for calling me out there. All right. It's k plus 2. Would that make more sense to you? Yes, at least I know you're paying attention, so good job. All right. Now this makes more sense, right? Now can I drop my 3's? Yes. So this gives me 2k plus 2 equals 5k minus 1. So this gives me 3 equals 3k. K equals 1. Everybody okay with that? All right, so on number 4, can I drop my 10's? No. This would give me 10 to the negative 4 plus 9 power equals 10 to the v plus 4 plus 2v minus 11 power. Now you have a single exponential on each side. You can drop the 10's. When I combine that, that gives me 5 equals 3v minus 7. Add 7 to both sides, and we get 12 equals 3v. V equals 4. Any questions at all? We all good with that? So you have to have they have to have the same base and a single exponential on either side. So when we look at type 2 here, if they don't give us, all those gave us a common base, and we had to do a little bit of rearranging, but here I don't have a common base. But I need to try to see if I can get one. You can't always get one, but in these cases that we're doing right now, you can. My base on the left is 6. Can I change 36 into 6 to some power? Yes. To what power? The second. Okay. So this would give me 6 to the 2x minus 10 equals 6 to the second. So now I'm just like what I had up there. I have two single exponentials with the same base. So now this just gives me 2x minus 10 equals 2. So 2x equals 12 and x equals 6. Any questions at all? All right, let's jump to number 7 then. What do you think we want our bases to be? 7. So the left-hand side can stay the same, 7 to the 4x plus 11 power, 7 to the negative 1 power. Very good, because that's how we get the reciprocal there. So now we have 4x plus 11 equals negative 1. So 4x equals negative 12, x equals negative 3. Any questions at all? All right, we're going to go to 9. We do not have congruent bases or equal bases, so what do you think we want to try to make our base be? 3. So 27 is 3 to what power? 3 times 3 is 9. 9 times 3 is 27. So it's 3 to the third. That's replacing 27. So all of that is to the 2x plus 6 power. That's equal to 3 to the 2x. Everybody with me so far? If I multiply two terms with the same base, I add the exponents. When I have a power to a power, what am I doing with those exponents? Multiplying. So this is 3 to the 3 times 2x plus 6 power. Be very careful and have parentheses there so that you distribute correctly. Now I have a single exponential on either side with the same bases. I can drop those bases. And when I distribute that 3, that'll give me 6x plus 18 equals 2x. So 18 equals negative 4x. 18 divided by negative 4 equals x. So what does x equal? Negative 9 over 2. All right. Any questions at all? Okay. Shouldn't be brand new, so it's just probably been a minute since you did it. We're going to go to number 12. So on 12, bases are not the same. 8 is the smallest base. Can I change 16 into 8 to some power? No. I do know that 16 is 4 squared. Can I change 8 to 4 to some power? No. Okay, so what's another option I have? 2. Okay, so my 16 can become 2 to what power? The fourth. 2, 4, 8, 16. So the fourth to the 3x power equals 2 to the what? Third to the x plus 2 power. So that means I'd have 2 to the fourth times 3x and 2 to the third times x plus 2. Don't skip too many steps because that's when you don't distribute and then you start making up math there. So now I can drop my 2's and that'll give me 12x equals 3x plus 4. No, it doesn't give me 4. It gives me 6. Good Lord. All right. Then that'll give me 9x equals 6. X equals 6 over 9. So x equals what? 2/3. Good. Any questions at all? We good? All right, let's look at 14. What do you think we want to make our bases be? 3? 3 works. I could use 1/3, but I don't think I want to do that. I think 3 is a good idea. So 81 is 3 to what power? 3 times 3 is 9, times 3 is 27, 27 times 3 is 81. So this is 3 to the fourth to the 2x plus 5 power. 1/3 would be 3 to what power? -1 to the 2x power. So that means I have 3 to the 4 times 2x plus 5 power equals 3 to the -2x. Now you can drop your 3's. I'm going to distribute that 4. Hopefully I can do it correctly this time. 8x plus 20 equals -2x. So 20 equals -10x. X equals -2. Any questions at all? We good? All right, we're going to jump to 17. Okay, so what do you think we want our bases to be? Like, we could break it all the way down to 2, but could we use 4? Can you make 64 into 4 to some power? Yeah, because 4 times 4 is 16. 16 times 4 is 64. So, but then over here, I have a 4 times 4 there. Let's just go ahead and put 4. This is 4 to the third power. This actually means 4 to what power? The first times 4 to the 4x, right? And if I multiply two terms with the same base, what do I do with the exponents? Add them. So this is 4 cubed equals 4 to the 4x plus 1 power. Everybody with me? Now I can drop my 4's and get 3 equals 4x plus 1. So 2 equals 4x. X equals 1/2. 2 over 4, which is 1/2. What questions do you have? Anything? All right, then y'all work on 19. And you can talk to your neighbors.
Do you ever get stressed out with people like every time like any questions?
Oh no, not unless they're doing it to be a jerk. You know what I mean? Like I had like a long time ago, early in my career, I had this kid that every time I'd say, "Do you have any questions? How fast does a cheetah run?" Every time, how fast does a cheetah run? I don't know. Look it up. I'm like, oh. If you truly need to know, it wouldn't irritate me. If you were just doing that to irritate me, then it would probably irritate me. Oh, shoot. Making stuff up. X equals 6. If you didn't get that or don't know where anything came from, let me know. Do we have any questions at all? Okay, you do not have to do this entire worksheet. You only have to do the evens. And the answer to, do you have to do both number 12s? No, you don't. You're basically just doing all the questions over on the right. Okay? There's 2 number 12s, but yeah. Just the questions on the right. That's all you got to do. Oh, on the assignment. Yeah, you don't have to. No. You don't have to do any more on the notes. Yeah. On the assignment I just gave you. It's right there. There you go.